I know we have two more out there, but welcome, welcome. Especially on a night like tonight. You never know when they say there's a winter storm warning here, you don't know if that means you need sunscreen on and not a coat. You may need a coat and you may need boots, who knows. But I actually hope that we get snowed in tonight, which I don't think will happen. But anyways, welcome, welcome. Care_more, password, sorry about that. And also grateful that Rob's here to present tonight. He has a lot of topics he could present on. We're trying to actually start with some basic things for those that maybe haven't had that many years in Kubernetes land or container land. And Rob's very good at that orientation. And also there's a lot of people that have been around the block that can contribute as well. So we're grateful to have you here. As we talked about in the beginning of all of our meetups, we are part of Forge Utah. And Forge Utah is a great organization of 6, 7, 8-ish meetups, and then just a great community of people with job listings, opinions of many a sort. And so it's if you're not part of Forge Utah, please join. And after you join, please join the conversations out there. That's really a good forum. We do have other meetups, as I mentioned. Here we have on the first Tuesday of the month, we have Go Meetup. We have then this, we've had machine learning.
We have the MLOps and AI Utah. We have the Data Engineering Utah. We have one and down in St. George. We have occasional engineering leadership.
Yep.
And we have Foundry, that's mine, on the second and fourth Thursdays.
Yep.
I think that's the big ones.
Yeah, I think that's true. Anyways, lots going on, lots to be a part of if you want to be. We do have these recordings that will be posted soon after. They're out under our YouTube Forge area. There are many from many a year back. And so there's a lot of all of these, well, most of these meetups are recorded there. So if you've forgotten one or weren't able to go to one, it's always a great resource of a lot of things in there. I kind of do the water cooler, any things happening in people's lives, of jobs, needing jobs, anything interesting, any tidbits of trivia when it comes to technology, anything happening?
It snowed today.
I saw 2 snowflakes, that's all I saw. I don't believe it. Huh? You saw snow? Okay.
My way to Salt Lake.
Okay, well, maybe it does exist in this time. Very good. I just have a quick question for those that are here, since I'm always asking people around when I have a chance to see how AI is affecting or helping or changing, or all of those and more, your jobs. And specifically, please.
Let's me go faster, just more. Yep. The other tools, finding it. Want to adopt it. Better.
Welcome. There's pizza out there of various sorts, so just open boxes and grab.
Thank you.
Please, welcome. Yeah, I think that's true. I think I've seen both sides and everything in between. You have those that are really pushing against it, saying it's not going to happen. We're talking about AI affecting you in your work. And then the others are adopting it in various ways and finding great productivity. So I'm interested to see, and maybe we'll see in the future in some of these meetups, how it plays into the Kubernetes space. I think there's a lot there that is going on, and we'll probably be beneficiaries of that effort. When I think about a lot of the early days of what we had to do, that a lot of the AI can fix a lot of that. And we had several years ago, actually had it twice, several people come in about different opportunities of how to be more cost effective in cloud spending and Kubernetes. And I'm thinking that it's going to be a really interesting space where we'll see a lot of AI changing that and helping out in that role. So anyways, welcome those that have been here a while and those that may have been here before or the first time. Welcome, welcome. So again, Paul McKay, joined Forge. Wonderful. Pete's out there. Great.
ForgeUtah.tech.
Yep. ForgeUtah.tech. That's with a H?
Yes, TECH is the TLD.
Yep. Okay. I'm going to give it over to you. We usually do as we normally do, whenever you want to finish. Do you want to have questions during the presentation? Okay. Just
Yeah, if you've got burning questions, definitely interrupt me. You know, this is for you. I already know what's going to happen, so
That's good.
where you want to go instead.
That's good. And then usually Q&A afterwards and then just mingle. So we are recording. As I mentioned before, these are really great mics. I do edit. So let me know if I need to edit even more. But anyways, take it away. And thank you again for being here.
Yeah,
And I'm going to take out the door since it locks.
yeah. Yeah, and I probably won't see chat, so if you post something in chat, you know, somebody in the room ask it and I'll flip back over to chat. I really love this talk because it shows the entire DevOps pipeline, starting with nothing, going all the way up to deploying content into Kubernetes. And so that's what we're going to do. We're going to scaffold out a website. We'll live code a Docker file. We'll live code a Kubernetes YAML file. We'll push that up to GitHub, live code a DevOps pipeline, and deploy that content in Kubernetes. We don't have anything in Kubernetes yet, and our repository is empty. Here's the part where I tell you, I am definitely going to post the slides on my site tonight. But in this talk, there are no slides, which is perfect. But the code is online right now, github.com/robrich/full-stack-DevOps Kubernetes. And so you can go there and you can see the code that we're going to build tonight, which right now is empty. This is pretty much an empty repository. I did commit a README so that there was something, so it wouldn't be totally empty. And I have created some secrets in this repository too. So that saves us a little bit of typing and a little bit of stopping screen sharing. So let's fire this up. Now, the first thing I want to do is create a website. And we could code the website, but you know that's a solved problem that we can do in other places. And so instead, I'll use Aspire to do that. I'll just say Aspire new. And Aspire new will give me options for what I can do. I'll do a ASP.NET Core and React project because that'll allow us to do a multi-stage build and also a front-end statically hosted site, and that'll be really cool. Full stack DevOps. I'll put it in the current directory. No, I don't need these. No, I don't need Redis. It will go find my templates, and then it will ask me if I want to save a NuGet config. No, that's not relevant. And so now we've got some content here in this repository. Now, if this was an Aspire talk, I would talk about how we use Aspire in interesting ways. But in this case, because we just needed a website, I'll kind of let the Aspire pieces kind of melt away. I'm going to create a new folder, and I will call this API. And I'll move that backend content into that API folder, and then rename the front end to just app. And that's a pretty good convention where the front end React stuff is in an app folder, and it then contacts out to the API to do interesting things. Now we do have some Docker ignore and git ignore stuff, and so we don't want to cheat the demo there. And so now we've got our content. Let's open up this in VS Code and take a look at all the things. I do want
Get the
to.
font up just a little bit. That'd be helpful back there.
It should stop the slides.
I can see. Lights could help.
I'll get the lights down and maybe the font up.
Actually, the lights down would help. Yeah, thank you.
Thank you.
No sleeping.
I've always been a back row sitter is the problem.
I definitely don't want to do that one.
Oh, yeah, that's better.
Control Shift Plus. Control-Shift+. There we go. Cool. Let's go into the API folder and .NET solution migrate. That will get us a new solution file, and then we can get rid of this old hacky one. That one's gone. Now we have an XML file. That's a whole lot easier. Okay, XML, fine. But I'm going to remove the front end one because we don't need to build our front end in Visual Studio. We're not using Visual Studio today at all. And here in the app host, the app host also has a reference to the front end, which is no longer there. It's the app folder. And I'm going to say if builder is development, so when we run this inside Visual Studio, it'll start up all the things, and that'll be great. But when we do this inside of Docker, then we don't need that part. I do need a using statement to make that go. Let's go grab that using statement, and now the app will kind of leave us alone. Cool. So we've got now this application, and let's play with it a little bit. I'm going to pop open the app, and it says Aspire Starter. I'm going to say Utah Kubernetes instead. Let's come into our app.ts, and let's go to the repository for this talk instead. We'll set that right here. Full stack DevOps Kubernetes. And then let's also, instead of going to learn more about Aspire, let's actually go to this meetup. So let's go grab the meetup URL. I will set that there. Learn more about Utah Kubernetes. And up at the top, we can say, instead of Aspire Starter, we'll say Utah Kubernetes. Now, VS Code is mad at me because I didn't npm install yet. Yeah, we're not going to npm install, so that can just be what it is. Cool. So now that we've modified our website so that we can just see particular things, let's close that and that. Now we do have the back-end API and the front-end React app, and they're doing the things. Our next step is to craft a gitignore file. And so of course I pull up GitHub Copilot and I say go craft me it, and nah, let's just do it. So I'm going to start with my API, and I'm going to say, let's craft a gitignore file. And we can start talking about what we might ignore. The bin, the obj, Let's be a little bit more methodical about this gitignore file. There's five types of things that we don't want in our repository ever. Downloaded files. Built files, user-specific files, temp files, and secrets. And let's pop that one back open. If you've ever looked at a gitignore file, you can kind of take all of those things and break them into those 5 groups. And the cool part about it is when you think about those 5 groups, you can kind of look at each group and go, well, this is the things that go in that group, and this is the things that go in that group. And so at that point, then you don't have to futz with, well, where does this go? Do I need to ignore that? Is it one of these groups? Then you can ignore it. So here in the .NET project, downloaded files, we don't have any. We'll leave that section blank. Built files, we have the bin and obj folder. We'll also have a dist folder. Depending on the type of website, you might have a dist folder inside of your client-side libraries that you downloaded, so you might want to be careful there. Towards user-specific files, we have the .vs folder, star.suo, star.user. And so now we've got those user-specific files. Towards temp files, the .ds store file, we might have star.log or other things. And so now we've kind of dialed out the things that we never want to put in our GitHub repository. Excellent. Secrets. Now, towards secrets, we might come in here into our app settings, and we might say, I have some connection strings, and here's my default connection, and by the way, here's the link to my database. Now, we want to be careful here because that would commit a secret into our repository. So I'm just going to say use envars. In production, we want to use environment variables to configure our database connection strings. We don't want to just put them in config files. Perfect. For local settings, we want to do a similar thing, but now we want to say use user secrets. And user secrets is a cool .NET way to move the .env file into your user profile away from your source code. I happen to have the user secrets plugin installed right here, and so I can go click on my CS proj, and I can say manage user secrets, and now it will set my user secrets ID, which, yeah, that user secret ID, the GUID isn't necessary, it just needs to be something. So let's call it full stack DevOps. And that user secret now will get my secrets outside the repository into a way that I can discover it in my user profile. I'm going to copy that one into the app host as well, just to keep the user secret consistent across my application. And now the cool part is, because I didn't commit these secrets here, I don't need to exclude these files here. Which is great, because now I can have all of the defaults associated with my application just checked into my repository. So the various configuration details, and I can still override them in user secrets if I need to. Great, we have a gitignore file. Now this gitignore file is perfect for a back-end application. Let's build a similar gitignore file for a front-end application. So here in our app folder, new file, .gitignore. Now, do we want to create one gitignore file in the root of our project instead? We definitely could, and the root, the gitignore file in the root might be perfect for things like .dsstore, star.log, star.orig if you're in the middle of a merge. You know, just those types of things might be great for that central gitignore, and then the technology-specific one can be in each folder. In the SQL folder, we might want to exclude star.back and star.zip in case we restore a database into our SQL folder. So now towards the things that we need to ignore in our front-end application, we still have these 5 groups: downloaded files, built files, user-specific files, temp files, and secrets. But in a node project, these are different. So node modules I downloaded, built files, I'm going to end up with the dist directory when I do my Veep build. User-specific files, package lock.json is one of those. We can definitely argue about, is this a built file? Is it a user-specific file? Should I check it in? Should I not? And when we're over a beverage, let's definitely argue about that. But the important part is that I just don't want that thing in my repository. We're never going to merge it. We're never going to resolve conflicts. We're always just going to, let's just ignore it. dsstore, star.log, and then secrets, we might have a .env file. Cool. So we have our gitignore file for both the back end and the front end. And our next step is to containerize this application. Now, why did we start with a gitignore file? Because a Docker ignore file has pretty much the same syntax as a gitignore file. So we can take this gitignore file for our backend, and we can create a new file and call this .dockerignore. And now we can take our gitignore file and just paste it into place. Nice. Now there is one more section in a Docker ignore file that is not in a git ignore file, and that is non-production files. We definitely want these in our repository, but we definitely don't want these in our production container. These are all of the things that, well, help us with setting up our project locally, but have no business being in production. So here we have the star.http. We have the app settings.development.json. And then we also have this launch settings.json, which is the things that we would configure to start up our app. What is the temp URL, things like that. So those are the three big files that the non-production files that we want to ignore in our Docker ignore. Now the other main difference between a Docker ignore file and a git ignore file is that a git ignore file will will recursively look through all directories, ignoring anything that matches this file path. By comparison, a Docker ignore file assumes that you're rooted at the start of your directory. So let's do a little regex magic. Let's look for the beginning of a line, followed by not a £, and that will go grab each of those, and we'll say, I want that to be */ $1, and now it will recursively look through all the directories to accomplish this. Nice. Now we have a Docker ignore file. This is everything that will never end up in our container, even if we very specifically copy the file into our container. If it's in the Docker ignore file, it just won't get into the container. I hope that saves you the hour that it took me to figure that out. Why is this file not copied? Oh, it's in the Docker ignore file. So let's do a similar thing for our front-end app. Let's go create a new file, .docker ignore, and we'll do the same magic. We also have non-production files, and in this case, we could start talking about, should we ignore the vite.config? Should we ignore the eslint config? The vite config probably also has some build-specific things. ESLint has rules that we may flex as part of our build. So I'm going to say that in spite of the fact that we don't want to deploy those files, we will need those as part of our build. And so in this case, I'm just going to leave that section empty. Let's do the same regex magic to look at every directory. And we now have our Docker ignore in both places. File, save all. Cool. So we've scaffolded out our application. We've built a git ignore and a Docker ignore file. Any questions so far? Any thoughts or concerns? Any mistakes I've built yet?
Seems reasonable.
Looks good.
Cool.
Good.
So our next step is to build a Docker file. Let's start with our backend application, and let's build a Docker file. New file, Docker file. And of course, yeah, we could use various tools to automatically generate this, but let's craft it to ensure that we are using Docker best practices and also that our container is as small as possible. From copy, run, cmd. There are other commands in a Docker file, but for the most part, those are the big ones. From, copy, run, and cmd. If you know these 4 commands, you can build a Docker file, and you can read a Docker file. Now there are others, we'll see more tonight, but these are the 4 main ones. Now I happen to have cool icons here, I have IntelliSense going because I have GitHub Copilot, but I also have the Docker, the Container Tools extension, and also the Docker DX extension that's kind of helping me along, which is really nice. Now this is a .NET project. It happens to be a .NET 10 project. We can verify that by popping open our CS proj, and we see that that's .NET 10. the particulars of .NET can kind of just melt away. But now, next we want to go to Docker Hub and go find the containers that we want to look at. So of course, I'm going to come up here and I'm going to search for .NET, and I'm going to land on this .NET repository that will show me the various, this is kind of a meta repository. It shows me the various repositories that I can look for. Samples is good, lots of different Docker files that I can choose from. The Aspire dashboard is really cool. Monitor, how might I monitor an application? The shortcut there is use Aspire and OpenTelemetry. Runtime Deps is cool. Runtime Deps is everything I would need to install .NET, but .NET isn't installed yet. On top of that is Runtime that will allow me to run .NET console apps, but not websites. ASP.NET allows me to run websites, but not build. And then SDK allows me to build .NET applications. And so that's the one that I want to start with. So we can pop that one open, and we see that there's the repository that I want to grab. Now there is a .NET 10, .NET 9, .NET 8 version. And so let's come back in here from that. Now the interesting thing is if I flip over to mcr.microsoft.com and search for Alpine, there is a 10.0-Alpine variant of this. And Alpine is a very, very small version of Linux. By default, it's either using a Debian or an Ubuntu-based thing, and there's some pieces there that I don't need. Alpine is great unless I'm in a Python project. And in a Python project, then I need to compile my own wheels, and the Alpine C++ compiler is a little bit different than the Ubuntu C++ compiler. So using Alpine with Python is probably not a great idea. But outside Python, it can be a great way to make your container smaller, just because the things that you have underneath you is also small. Now, we also want to make sure that it has the tools that we need. So, you don't want to have to apt-get install all the things, or in the case of Alpine, sudo add all the things. But, if you can find a good base image that has the things and is also built on Alpine, that will probably be smaller. Next, we want to copy all of the source code from our directory here into the current directory in the container. Now, where is that current directory? Well, let's go define it. workdir/src. Now, we could choose to make it anywhere. var lib foo bar, and it will recursively create and cd into that directory. But in this case, src is fine. If we don't create a workdir statement, it'll put it in the root, and we know just how bad running out of the root is. So having a workdir is a really good idea. So I've just copied everything from the directory where I'll run my Docker build command, this API directory, into that src directory. Next, we want to run stuff. Now, when we run stuff, we want to run the various build commands that we would want to do. Oh, there we go. .NET restore, and in this case, we want to say full stack devops.slnx. I need to specify it because I specifically said I wanted to flip over to the new XML one. .NET build, I'm going to build in release mode, and I'll go out and I'll build that full stack devops.solution. I also want to run .NET test. I will also run test in release mode. If I were to test just without the release mode, it would create one release build and one debug build in my published container. I definitely don't want to do that, so I'll very specifically say, let's go in release mode. And then publish, I'll publish in release mode to the app directory, and I'll specifically publish the full stack devops.server, full stack devops.server.csproj, because that's the one that I want to deploy. Cool. So I've run those console commands, and by putting run in front of it, now it's a Docker command. It's just going to run that on the console. So let's,
Rob?
Yeah.
Is that /app or /source that you want? Because it's app's not been created, right?
Right there. I want it to go out into the app folder. Well, probably I want it to go into the dist folder eventually, but let's make it the app folder for now.
Do I have to create that within inside the image?
The Docker publish command, or the .NET publish command will actually create that directory even if it doesn't exist.
Don't you know .NET? Come on.
Not .NET, I apologize.
With the Go meetup and the Python meetup and the DevOps meetup. Yeah, in hindsight, maybe .NET is not the greatest example here, but it does kind of help us do some interesting things coming up. So
It's great.
and it gets
some horizons. It's awesome.
Done some dot.
So let's set the URL that we want it to run on, expose that. We'll set the environment, and we'll also set the database connection. Now we're very specifically going to leave this blank because we don't want to check in secrets. We want to inject that as we start up to be able to get that database configured in the way that we want. And then we'll switch over to that work directory and we'll fire up our server. Yeah.
Does the environment command happen on in the Docker image or in the instance when it's spun up?
Does the environment happen in the Docker image or the instance that it's spun up? Great question. Kind of both. Every time it does a command like this, it will actually spin up a container, do that thing, and then save that layer into place. And so this actually does it at build time in this spot, but when I run this command, that environment variable is still set. So by the time I run this command at instance startup time, then all of these environment variables are set the way that I've configured it to be. And I might, on the Docker run command, actually give it some overrides because I want to adjust environment variables in interesting ways. But I kind of like this default and this default, so I'll just set them right here. That was a great question. Did I answer your question?
Yes.
Sweet. So this is a great Docker file. We got the things that we needed accomplished, and we could choose to run this in production. But let's leverage some Docker best practices here. One of the big Docker best practices is you don't want your source code and your build tools in your production running container, which since JavaScript is interpreted, not compiled, that's why this isn't a node server. And I have my build tools and my source code in this running image. Let's see if we can separate this. So back on Docker Hub, we can take a look at the SDK. That's the one that has the build tools, and ASP.NET is the one that just has the production runtime to be able to launch web servers, but no build tools. So if my container got compromised, if someone uploaded source code, they couldn't compile that into place and replace my running server. That's kind of nice. So let's split this image in half. Let's go like this. And I'm going to switch this out with ASP.NET, and there does happen to be an Alpine variant of that. And now we have two different builds. Well, two different images that this will create. This is the production runtime server image, and this is the build server image. Now, I put server in air quotes because that's a good mental model for this, but it is a Docker container image, not a server. So we can think of it like a server, but it's not. So the cool part then is this is the build server where all my source code exists and all of my built asset, all of my compile tools exist. And then I'm going to go out to the dist directory here. And then this spot is the production runtime image that doesn't have build tools, doesn't have source code, doesn't have all my test results, doesn't have any of that stuff. It's just the running image. So now I need to copy from the dist folder into the current folder, into this app folder. Now right now it's going to go look for a dist folder out here, but I very specifically told it to ignore that dist folder, so it's not going to find it, and so it's going to have nothing to run. I don't want to copy it from out here, I want to copy it from up here. So let's name this one as build, and let's copy dash dash from equals build, and now that content will get into place. Great. I took my single stage Docker file and I turned it into a multi-stage Docker file. It's going to produce 2 images. Now, if I said Docker build dash dash target build, it would build this stage. If I didn't pass in one, it would build the last stage, in this case, this one. And so I could name this as final, as runtime, as production. I don't need to name it. Just Docker build will do fine. And so it will notice that it has this dependency and go build this stage and then copy it into place. Now the interesting thing is I've very specifically put this command as far down in the Docker file as I can so that it can do a bunch of things in parallel. It can do all of the building. It can also, maybe I need to run apt get install stuff. Now this is Alpine, not Ubuntu, so apt-get isn't a thing, but we can imagine that I can put install commands to add additional libraries there, and that could happen in parallel. We're building while we're installing our runtime dependencies. Do you have a question?
Does that ever lead to concurrency issues if there's any work that needs to be shared between images?
Does it ever lead to any concurrency issues if there's work that needs to be shared? The cool part is that the Docker build engine is able to resolve those dependencies. It knows that because this copy command says that it depends on that other stage, it's going to wait for that other stage to finish before it does this line. But all these other lines don't have dependencies, so it'll be fine. Now, if I have a wacky dependency where it's like, and this one copies it out of the container, and this one copies it back in, it's like, it's hard for it to do that. But as long as you're using standard Docker commands to be able to identify your dependencies, it's really good at resolving those. To that end, it can also resolve that, maybe I don't need to build that other stage because I'm targeting this stage that doesn't depend on it.
Okay, that answers my question, thank you.
Yeah, Docker BuildX is awesome. When that came out, it was like, and now they're fast, they're in parallel. Cool, so we have a Docker file, and we talked about some best practices for how to get this Docker file to be awesome. There's one more thing that we can do. We can take advantage of layers. Now, when we typically talk about layers, we talk about, let's do this in one command, and we definitely could do that. String all 4 of them into one big command so that it only has to write one layer. It doesn't have to write. But because this is the build server, and I'm going to throw it away, I kind of don't need to do that optimization in this case. I might try to optimize my end lines to get them into one spot, but end lines are not a huge hit to my Docker image. Where I might want to optimize this is where I would do a apt get update and an apt get install something, and then afterwards clean up after me. Because now I don't write all the layers of the temp files, I just do the thing and then it just melts away. So in this case we have no dependencies, so we won't do that. But another way that we can look at layers is here. We copy all the files, and this layer will get cached, and then we restore our dependencies. So that means if I come in here and I modify a little C# file, then I'll have to restore my dependencies. If I'm running this locally, that can get kind of time consuming. My dependencies haven't changed, I'm just reinstalling them because really what I want to do is I want to .NET restore first and then copy in all my stuff and then build, test, and publish. Now if I modify some C# or some JSON, it won't need to reinstall all my libraries. Now I do need to install all my manifests, or I do need to copy in all my manifests. So let's copy in all the manifests there. And then we will run .NET restore. Then we'll copy in everything else, all of our source code, and then we'll build, test, and publish. Cool. So because we've now restored our dependencies, our libraries, based on our manifest before we copy in our source code, as we're debugging locally, it will actually rebuild faster. Cool. We have a Docker file. This Docker file is great. We use best practices to leverage layers, make sure that it's really small. We also leveraged Alpine to make sure it was extra small. And we also separated this into multi-stage build so that we didn't get our source code or our build tools into our production image. Cool. Let's do that for our front end as well. Here's our app, and we'll say new file, Docker file. And now we'll do from node Alpine, workdir is src, copy package JSON, run npm install, copy everything else, run npm run build. That will put things into the /src/dist. And now we could do a CMD like npm start, but this is a React app, and our goal is to create static assets. So instead of doing an npm start, let's do something different. Let's say from nginx Alpine. Now nginx is a great small web server that doesn't have Node installed, it doesn't have all the, and so it's a much smaller attack surface. And now we can avoid all the dependencies. We can just host static files in it. So I'm going to specifically copy in the nginx.conf here, and let's go find that nginx.conf. Here's the nginx.conf right there. And let's take a look at what is that nginx.conf. That nginx.conf allows my front-end SPA to use client-side routing, even if I don't have server-side routing, because, well, it's a static site. So I'm going to go look for exactly that URL that they asked for. And if that exists, then I'll serve it. If not, I will try to serve it as a folder, which, by the way, will add .index.html to the end. And if not, then I will just serve the index.html page. So if I have /customer or /order or /user, any of those routes will now still resolve and serve my home page so that I can boot my client-side app and then use my client-side routing to get to that URL. So that's really cool. I can now put this into, I can now put my static resources in here, and it will just serve my SPA. So I've got that. Now let's set our workdir to user share nginx HTML, and then I will copy source dist from build. Let's name this one as build. And then nginx already has a CMD line, so I don't need to start up something as my container starts, as my container instance starts. Cool. We did that same best practice of not putting our build tools in our production image, of copying our manifest and then installing our dependencies, and we copy this as late as possible so that we can do as much as we need to in parallel. Cool. We've got a Docker file. So we've got the gitignore file, the dockerignore file, and the Docker file for both our front-end app and our back-end app. We're able to use Docker best practices, and all of those pieces are now in place. Any questions or thoughts, concerns on these Docker files or anything we've built so far? Cool. So let's put this in Kubernetes. Now, depending on how we run our teams, we might choose to put a Kubernetes YAML file in each thing of our monorepo, one Kubernetes file on our back end, one Kubernetes file on our front end. We could definitely do that. In this case, let's just deploy both parts in both sides. So I'm going to create a single Kubernetes YAML file, k8s.yaml. If this got particularly complex, I might create a Helm chart that would allow me to template this in interesting ways, but this will be good. Now this is a YAML file, and I specifically have the Kubernetes plugin here that gives me some really cool templating. I'm not sure if it's the Kubernetes one or the Red Hat YAML one. That one's pretty, the Kubernetes one depends on that one, and that's pretty cool. But because I have that, I now have some really cool snippets. So I can say, go gadget, give me a deployment, and it goes, here you go. Nice. So I'm going to say this is full stack API, and I love how it fills in all the places. I'm going to give it replicas of 1. I will give it an image of ACR URL / full stack API, and I'll actually give it an image label there. I'll add another label here that is a version, image label, and we'll actually label. We'll replace these at build time, these replacement expressions, the URL to my private registry, and the image label that I want for this image. Now I'm going to say 128, an eighth of a processor, and that's probably sufficient. And my container port is port 5000. Nice. Now this is mad because I set the resource limit, but not the resource request. I could definitely do that, or I could even take it a step further and say, I don't want to define anything, I just want to create an empty object, and then VS Code can be mad because I didn't specify the particulars in there, but I don't know, the limits is completely sufficient in this case. Now I also want to define some environment variables. ASP.NET environment, production is great, ASP core URLs 5000, and we have our default connection string where we actually put the details of our database connection. Well, kind of. If we put it here, it now is a file with secrets checked into our repository. So I'm going to say to do move to KDS secret. And I will leave that as an exercise to the reader. But if we create it as a secret, then we can pull that in. Maybe we create a secret per environment, and so now our dev secret is just in place, and our prod secret is just in place. And now we don't have to worry about having to specify those secrets here. Cool. So we've got our environments. We've got those. Let's now create a, service. And this will be full stack API. The selector is full stack API. We won't specify the, thank you GitHub Copilot. We won't specify the type because cluster IP is fine. And we won't specify the image label because we want the service to be durable across all of our deployments. So that when we do another deployment, the service will just catch all the new pods that exist. Cool. Let's do a deployment for our front end, full stack app. And our replicas of 1 and our image label of yes please. We'll give it a version of image label. We'll give it an eighth of a CPU, and our port in this case is port 80. That's what Nginx runs on. Now in our Vite config, we did specify that we wanted to proxy off to our API, and it's looking for the specific server URL to be able to do that. And so we're kind of using Vite as our reverse proxy. In this case, in Kubernetes, we're going to use a Kubernetes ingress as our reverse proxy. And by the way, in this Docker file, we're running a static thing. So any environment variables that we need in React actually have to get baked into the React build step up here. So there's no environment variables down here that we need to set inside of Kubernetes. We can't set those environment variables. They would be server-side environment variables, not client-side environment variables anyway. And client-side environment variables just get baked in as part of the build. Cool. Let's create a service, full stack app, and full stack app. The port is port 80. And there we go. Next, let's build our reverse proxy. Now this is an ingress, and this will be the full stack ingress. We don't need this label. And the host will be full stack DevOps .aks URL. And so now we've got that that other replacement expression. Let's send that to full stack app on port 80. That's perfect. And so now if any requests come in, they'll go to our full stack app service, our React app. But let's add another entry in here that will send /API off to the API on port 5000. Great. Because we have this reverse proxy, we're now running both the front-end container and the back-end container on the same URL, which means from the client side, it's one website. We just completely avoided the whole CORS thing. We don't have to keep track of what is the other URL that I need to inject into my React app. We don't need to keep track of the CORS headers that we put inside of our API to be able to accept requests from that domain. All of that just melts away because from the React side of it, they're the same domain. It's the same site. So it just makes requests to /API/ something, and those requests just happen to go to this container instead of to this container. And then all the rest of the things, all the index.html, all the JavaScript and CSS files will get served by Nginx. Cool. We've got a Kubernetes YAML file. Any questions, any concerns, any things that I missed in configuring this? Yeah.
Ingress assumes that you have an ingress controller,
Yes.
and nope, that was the end of my thoughts, actually.
Yeah, it does assume that I have an ingress controller, and to that end, we haven't specified what that ingress controller is yet. Let's come back to that one.
Well, I mean, we probably shouldn't care, but you do.
Agreed. Yes?
Which part of this handles incoming traffic and which part handles traffic between the instances?
Ooh, good call. This ingress will listen on this host name and forward to these services. This service will then round robin load balance across all the instances of these containers. And so in this case, I have one container, so it'll load balance across the one. But all of these, this one then matches a URL to a service, this one matches a service to a particular instance of the container, and that pod is that wrapper around the container that configures it and gives it a network.
So the ingress handles incoming traffic and the service handles inter-application.
Yes. The ingress is the front-end firewall. The service is the load balancer across all the instances. Or in this case, the ingress is the reverse proxy, and the service is the load balancer. So I want to configure TLS. Now I did do all of the cert stuff inside my repository. I did come in here and I said, well, I want to do the deployment and the service. Those don't care about that. I'm going to go grab Cert Manager, and now I need to give it some details. So I'm going to very specifically come in here and I'm going to go grab this part. And let's replace this. Now I'm very specifically saying let's use Let's Encrypt. That's a great mechanism for getting certificates for free, by the way. I don't have to renew them. I don't have to figure out about cert expirations. It just does it, provided I have inbound traffic, which means if I put Cloudflare reverse proxy in front of this, then I can't, and so now my cert will expire. I'll give it an Nginx class name, ingress class name of Nginx, so that I can use the Nginx ingress controller. And then I will specify my TLS details. Here's the TLS certificate I would like you to get, and I would like you to store it in this secret. And because this URL and this URL happen to match, then now my website is secured with HTTPS. That's cool. Now I did need to do a little bit of like getting the certificate manager set up, and in particular getting a, as you deploy Cert Manager, you also have to set up a issuer where you give it the staging or production server and your email address, which they won't email anymore. That's a bummer. And specify the secret name. You have to do that per namespace inside of Kubernetes, and so that's kind of annoying. It's like, well, I want this one to be this namespace, and I want that one, which means I need 2 cert issuers. You don't need 2 instances of Cert Manager, but you do need a cert issuer in the same namespace as your ingress controller to get that to work. Hopefully that saves you the hour that took me to figure that out. Cool. We've got our app. We've got our containerized mechanism in our Docker file. We've got our Kubernetes YAML. We're ready to push this up to GitHub. I also have this README that talks about this app, and that was in there before. So let's come in here and let's take a look at the things. Let's make sure that we're ignoring the 5 things that we want to. We don't want to commit built content or downloaded content or user-specific content or temp files or secrets. And so if we see any of those things in here, we want to take a step back and do a little bit more work to make sure that those are properly excluded. I like to spend a lot of time here in this commit dialog getting a feel for what am I committing. Let's take a look at each file. Let's make sure the diff works out correctly. Let's make sure that I'm committing what I expect, not just blindly committing the everything. That looks great, so let's commit this. Full stack app and containers and KDS. Oh, I haven't staged anything. Let's stage all the things, and now let's commit. Cool. So now, git push. Oh, I'm in the API folder. That doesn't matter. Git push origin main. So if you've been following along at home and you're like, but there was no code in the repository, and there's all the code that we built. We've got the Kubernetes YAML file, we've got the front end, we've got the back end. In each of those is that Docker file, the Docker ignore file, the git ignore file. All of that content is now available, and you're welcome to fork this repository or download it and continue learning. Cool. Now this was an empty repository, almost. I did come in here to settings, and I went into the secrets and actions, and I said, I would like to create some secrets here. Now I created a secret for my private Docker registry, the username, password, and URL. I got that from Azure. And then I also did my hosting URL, and then I also did my kube config. Now this kube config, and let's go find one. If I go into my user home directory, and I go into the .kube folder, and I open up the config file, which I am definitely not going to open, then I have a file like this. Now I pruned out all the things that weren't my Kubernetes cluster, like my Docker desktop stuff, my Podman stuff, and in this case I also snipped out all the secrets so that it wasn't so verbose or exposing my secrets to you. But that's the kube config. And so I grabbed this kube config and I said I would like a new repository secret, and I gave it a secret name, and I pasted that kube config right there. And so I have these secrets now that we can use in our GitHub Actions DevOps build. Cool. So now that I've got that, let's come into Actions. And we have a bunch of templates that we can play with, a bunch of places to get us started past the blank page. Here's all the things. It kind of looked into a repository and it says, hey, I think you're building an image. How about I help you with that? You've got some node stuff. Maybe Webpack is what you're looking for. It also looks like you might be doing some static stuff. Can I do a Jekyll build for you? But there's also deployment. I can view all to wander through all of them. some security scans, continuous integration, automation, pages, if I'm doing a static build. And so there's lots of different templates that'll get me past the blank page. And I can also start with a completely all the way blank file, which can be really entertaining when you're like, I don't want all the clutter. I'm going to start with simple because it has just enough to get us started so that we don't have to type the everything, but not so much that it will be overwhelming. Let's configure this. And now I'm going to call this full stack DevOps.yaml. Because I don't need to constrain myself to .3-digit extensions on DOS in 1985. So now let's build up a DevOps pipeline. So let's call this full stack DevOps. And now what do we want to build? Or how do we want to trigger our build? Building off the main branch sounds good. Let's do that. We could also specify other branches in our Git branching strategy if we needed to as well. Let's come back to pull requests. We'll set that one aside for now. Oops. They just added a bunch of stuff into their IDE that really slows down this website. Workflow dispatch is great. It gives me a build now button. If ever you've had to commit a space or a carriage return just to kick off the build, now you have a button to do that instead. So then what's it going to do? Well, we want it to build on Ubuntu latest. That's great. We're going to Linux Docker containers, so that's perfect. And then what are the steps that we want to do? We'll start by checking out our code. That's perfect. And then we can run a one-line command here, or we can run a multi-line command. Let's do a multi-line command. Let's build out the things that we want to. So I want to call this Docker build and push Kubernetes apply. Nice. Okay, I'm going to start by doing set-x, which itself does nothing, but it'll nicely echo the commands as it runs it, so that it won't just be the output of the commands, it will actually show me the commands too, which can be really helpful. It's like, error on, well, what caused that error? What command were you running? That can be really helpful. Let's cd into the API folder, and we will Docker build the -t full stack API dot. And that full stack API, I specified that here in the Kubernetes YAML file. That's the name of the image that I want to grab. And I also need my private container registry. So let's come back in here. And we do have a secret for the private container registry, the ACR URL. How might we use that? Let's flip over to the GitHub docs, and we can talk about how we might create secrets. So, you know, we did the secrets. You go into settings, and then secrets, and then you can create a secret. You could create an organization secret or an environment-specific secret if, you know, dev settings are different than prod settings, and that's great, a secret for an organization. And then how do we use them? I'll scroll down a little bit more, and we can see that now we have this syntax right here. $curly secrets dot, and then we can reference that secret. So let's do that. Right here, let's go grab the repository URL, secrets.acr URL, and now I have that private container registry. Excellent. I didn't need to specify it in this file. I don't want to get secrets into my my DevOps pipeline, and so into my GitHub repository. So I'll just do that. I'll also go github.sha, my git hash, and that is the git hash for this commit. Now that's definitely not Semver, but it's unique enough. I'm now going to have a different label per git commit. So if I have a different commit, it will produce a different label. I don't have to worry about latest in my cluster accidentally pulling the wrong image or having a stale thing. As I do a new deployment, it will have a different image, and now I'm assured that I'm on that new build. Excellent. Let's go back into our root folder and do that same process.
Sorry, Rob, the tag name in your YAML file, Kubernetes one, how does that label get there? I'm sorry.
How does this label get here?
Where's that image label getting the SHA?
Where's this image label coming from? That is a great question. Ask me in about 7 lines. Yeah, that replacement is going to be cool. So let's do the same thing for the app. Let's build the app. Now that's going to do all the steps in my Docker file. It'll run my build. It will run my unit tests. It will validate that everything works as expected. And now I have both of those. I've chosen to specifically build both of those before I pushed anything to make sure that this is a valid website. I might also want to spin them up, run integration tests, maybe fire them up in browser stack, and maybe I would use a reverse proxy to be able to proxy into these requests. And that could be a really, really elegant mechanism for being able to flex the site. So now, let's Docker push these 2 images. So I'll grab this one, and I'll grab the app one, and now they'll go up to my Docker registry. Well, kind of. I'm going to get an authentication error right now because I haven't yet authenticated to my repository. So let's come here into the marketplace and let's look for Docker login. Ooh, there's Docker login. Now, this I can go to the full marketplace listing. I can take a look at this thing. I can probably also browse to the repository for this. It'll give me lots of explanation about how I might use it in various configurations, and that can be great. And I have this snippet right here that I can just copy and paste into place. So let's copy it and let's paste it. And now let's fix some indenting. There we go. And let's fill in some details. What is my registry? We happen to have a secret for that. Let's go with secrets.acr URL. And what is my username? We have a secret for that. Secrets.acr username. And we have a password. Secrets.acr password. And we don't need ECR because we're not building to AKS. Logout is important, so, oops. Logout is important, and so let's set that to true. Now, if I'm on a shared agent, I want to very specifically make sure that I clear my container registry information and it doesn't leak into a subsequent build. And so this will very specifically say logout. Now, it doesn't log out at the end of this task, rather it logs out at the end of the build. Now, as part of GitHub's shared runners, it will always just destroy the VM that my build was on as soon as I'm done and reset it. And so, of course, I'm already logged out. But good hygiene says that would be a really good spot to do. So I'll log into Docker, and now when I push, now those things, I'm correctly authenticated to my Docker registry, and those will go up to my container registry. Next, I want to kubectl apply -f kdes.yaml, and Now, you had a brilliant question. So what about these replacement expressions? Like, I need to get those into place. Well, let's do that. Let's go grab these replacement expressions. And if I was doing a whole bunch of replacement expressions, I might want to use YQ, or maybe I would use Helm to build up a full Helm chart of getting these replacement expressions in place. But in this case, I'm just going to go low tech. I'm just going to use sed. Without a backup, I'll just go find ACR URL and replace it with the secret, AKS URL and replace it with the secret, the image label and replace it with the GitHub SHA, and I will do that inside the Kubernetes YAML file. Now I'm specifically doing it here after I've pushed the content up to my container registry. If I did it here, it's possible that maybe I forgot to ignore the k8s.yaml file and the Docker file inside my Docker ignore file. And because I forgot to do that, if I had happened to put this replacement expression up front, my build time secrets would end up in my production container. And if that container got popped, I would actually expose my build infrastructure as part of that server vulnerability. So I'm specifically not going to replace it up front. I'm going to specifically replace it only after I've done that push up to Docker, my Docker container registry. Now, I know those secrets won't end up inside my images, won't get pushed up to my container registry. Now, I do need to authenticate into Kubernetes, so let's come back in here, and let's come back to the marketplace, and let's look for Kubernetes set context. Ooh, Kubernetes set context. I could again look for the marketplace listing and go wander through, but I just want the YAML in this case, so I'm going to set that here and then play indent games because significant white space is awesome. There we go. So what is my method? Well, in this case, my method is my kube config. Now, I happen to have a secret for that kube config. We saw how I grabbed that out of my .cube/config file. Secrets.kubeconfig. And now, because I specified that secret, all of these other details associated with the Kubernetes configuration, the context, the cluster name, all of that stuff, I've already specified in my kube config, so I can just delete all of that. Excellent. So now I'm authenticated to my Kubernetes cluster so that when I do a kubectl apply, then it will get into the correct cluster. So there's our Kubernetes, our GitHub Actions DevOps build. On Ubuntu, on the main branch, or when clicked the button, let's check out our latest code, log into Docker, log into Kubernetes, build our images, push our images up to our container registry, replace our secrets in place, and then run that inside of Kubernetes. Yeah?
How much of this is just a shell script?
How much is a shell script? That much. And so the cool part is if I'm going to spend there we go, that much. If I'm going to move between, say, Jenkins to TeamCity to Azure DevOps, if I'm moving a whole lot, I might just put all of this in a build.sh and just have a script that says build.sh. I would have to pass it the various secrets that I wouldn't have secrets embedded in my build.sh. But yeah, I could just build a shell script for this, and then I wouldn't have such a verbose DevOps pipeline. I could also do each of these commands in a separate step, but it's like, I kind of like that it looks like a shell script, so that if I need to, I can just yank it out and actually put it in a shell script.
It should be a shell script for the most part, and I think that the other steps from the marketplace are pretty close with their convenience functions, and I like that. I like that.
Yeah. I agree. The majority of the plugins that we use are convenience functions, and so if I can use them directly, I'll just do that. Like there is a GitHub Actions Docker build and push command, but it kind of abstracts away the pieces of it, and I'm like, I just want to build and push. I just want to Docker build and Docker push. Like that.
A lot more YAML, yeah.
Yeah. There's a lot more YAML, there's a lot more ceremony, and it's also a lot more difficult to kind of get what's going on. The cool part about this is it's like, well, if it doesn't work and I need to replicate it locally, let me just copy these commands and put them in a build.sh and run it locally and just see if I can get similar results. Yeah, so there's our Docker build. Let's come back in here and let's commit our changes. Create a DevOps pipeline, sounds great. Commit our changes. And now we very specifically created a file inside of our repository. If we wanted to, we could just come back in this file, click edit, we have our marketplace again, but also because it's just a file in our repository, we can git pull and it will just be a file and we can continue editing it here in our IDE as well. So because there's a file inside the .github/workflows folder that ends in YML or YAML, and we haven't disabled it, we also kick off a build. So let's go look at that build and see what it's doing. Well, it's doing all of those steps. It's going to go authenticate to Docker, authenticate to Kubernetes, run both of those Docker build commands, push those up to our container registry, and then launch that in Kubernetes. So it looks like it's inside the node 1, doing an npm install of all the React goodness. It already did the .NET build and push.
If you open up the Docker login, the Kubernetes login, do those leak anything of details?
Ooh, good call. If I open up the Docker login, is it going to expose the secrets? Nope. Anything that it notices is a secret, if it finds that string anywhere in the build output, even if I like echo them, it will just turn it into asterisks.
What about your cubes config stuff?
Ooh, what about that sed line?
Well, that makes sense. Yeah.
That sed line is also start out.
Jake, could you look at that one?
The kube config?
A step above the Docker build. Set kube context.
Could you show the Docker one?
Yeah, that one.
It'll also be start out.
Yeah. Nice.
It's really good at hiding secrets. For the most part, if you set a secret inside of GitHub Actions, that secret's gone. The way you figure out what it is you go to the source and you set it again. Almost. You can create a task that will start an SSH server and then SSH in and like cat stuff. You can also cat stuff to a file and make it a build asset. You can also, there's other ways to kind of get these secrets out, but for the most part, once you've set it as a secret, it will stay a secret, and that is really, really nice.
You have to really try to get them too.
Yeah, you have to work really hard to get the secrets out. Our build went green. That's great. So let's come into Kubernetes and let's do a kubectl get all. And we can see that we have our 2 containers running. We have our ingress running as well. So let's come here and let's go to, we did the TLS, so HTTPS. And I'm glossing over the, I also did DNS stuff to make that URL work. And we've got our website, Utah Kubernetes. And we can refresh and it'll hit our API again and it'll, yeah, woo! The build went green first try, that's awesome. You have no idea how many times I practiced that to make that happen.
2 times.
And this will go off to our meetup page. And this will go off to our GitHub repository. And so, yeah, we've got our website going. It's awesome.
Oh.
The demo gods were with you.
Yes, the demo gods were definitely with me today.
Crazy weather this week.
Yeah. Yeah. What I love is that 98 is scorching and that 2 is also scorching. But 102 is just warm. And 91 is freezing. We can tell that it's completely random generated, random data. That's cool.
What's the command line command to check the status of the application again?
I said kubectl get all, and then I also added ingress to this, and it just spit out all the things.
Don't try that on a production server. You're running all the things. That will be too much.
Yeah, it'll scroll for a while. Cool. So,
Don't try that. Yes.
yeah.
In earlier, we have left database strings, connection string is empty. You said you will later on, you will inject them.
Yes,
Did we do that?
we did not do that. Good call.
We don't have a database to inject to.
We don't have a database, but here in our Docker file, not that Docker file, in our backend Docker file, we very specifically said there's a database connection string. In our Kubernetes YAML file, we set that connection string right here to, we ought to set that into a secret. And so we didn't create the secret, but that's the next step, is to create the secret that actually points to a database and, by the way, have an application that uses a database. Yeah.
Our databases and Kubernetes applications run as a Docker image with a server on it, with a skill server on it, or is there a service-based setup for that?
So how would I run a database in a Kubernetes cluster? Well, the ideal solution is that I would go find a platform as a service, some kind of database as a service rather, some kind of database running in the cloud. I would go into the Azure portal and I would say, new database, go give me a Postgres database, and it would configure it and do all the things. The cool part about that is they're going to take care of authentication and backups and all of those things. That wasn't your question, though. Your question was, so now how do I run it on Kubernetes? Ideally, though, that's still the best way to go. Provision it in Terraform and just let it be. If I wanted to run it in Kubernetes, I would instead create a new deployment here. And I would, instead of specifying my app, I would say Postgres. I'd probably need to give it more resources. I then would create a service in front of it, but now it's a UDP service instead of a TCP service, and so ports get a little bit weird. This also doesn't have durable storage, and so I would want to create a volume that maps in Kubernetes terms, that I would need a persistent volume and a persistent volume claim to make sure that that was stored in a durable way. And so I would kind of do that work to be able to get my database to just be one of the containers running in my cluster.
Because that would get discarded anytime the application was closed, right?
Say that again?
You said it's not durable. That means all the data in the database would be discarded when the application is closed.
Unless you did the
Yes.
Yeah.
Unless you do the persistent volume and persistent volume claim dance to actually get it to persist somewhere.
Right.
And that's the other thing of, so do database as a service, because they'll just figure all that out for you. Yeah.
I would go further and save like a ton of money if you're doing it on a side project kind of thing and use either Percona or Zalando operators. They'll do all of they'll not only do like the persistent volume claim with their own kind of bespoke versions of Postgres or MySQL or whatever database you prefer. They'll also have like read-write like replicas and failovers, and they work well with backups. You can use Valero to back up the persistent volume claim, all in a cloud agnostic way.
Yeah, Valero operator, Kubernetes operator is great at just kind of doing all the things. Operators are definitely beyond the scope of a 101 talk.
Yeah,
The more you
yeah.
use for operators, the more you forget how the real stuff works, which is why I don't typically say it here. But yeah, operators are awesome.
Percona.
Database as a service is still better.
Percona, StatGress is a good one. I like that one too.
Snackress I haven't used, but yes, I've heard of it.
Cloud native PG.
Yeah.
So what was the
Native
name,
PG.
what was the name of that again? Sorry.
The database ones are Percona. They're famous for a lot of managed database stuff. Zalando, which is much more open sourcey.
StatGress.
Snackress, okay.
And Cloud
Native PG.
And then the backup solution for like your whole Kubernetes cluster is Valero. This is all, well, this is like not at all.
Yeah, this is not 101, this is like 401.
Like more.
301.
You're kind of on your own if you're going down that path. Be prepared to do a lot of reading.
Yeah. Yeah.
Always check Valero twice at least.
I got here late, and it doesn't really matter, but what cloud were you running in?
I'm running in Azure, but the particulars of Azure just kind of melt away. We're just targeting Kubernetes.
Are you using managed Kubernetes, or are you doing that?
I'm using Azure Kubernetes Service to manage Kubernetes in Azure, but again, that's an implementation detail.
Just curious.
Yeah. And thus, Azure Kubernetes Service, AKS, ACR is Azure Container Registry, and so thus the acronyms that I've been using throughout. Cool, so let's do one more thing. We left pull requests off before, so let's do a pull request build. Now we could do a bunch of stuff in here to say if condition something, if, we could do some pieces to try and conditionally run steps in interesting places, but this pull request build is going to be so different that let's just create a duplicate build. So I'm going to go copy paste this, and let's say this one is the DevOps PR build, full stack DevOps PR build. And now I want to make sure that it runs on not main and also pull request branches of everything. Now, why do we have two? Well, for collaborators that are part of the project, they will probably create a different branch within our repository. That's where this top one comes in. Based on our Git strategy, we might be able to say those are feature / branches, but it's easier just to say not main. We'd also say not develop and not other branches that are sacred here. Then for outside collaborators, they'll probably fork it into their own repository and then do a pull request back into ours. And so this will catch all of those for internal collaborators and for external collaborators. And so we have both of those. We also still have the workflow dispatch that will allow us to do that build it button. Now we don't want to get a pull request build to deploy to Kubernetes, so let's delete that. Because we're not doing that, we don't need to swap out the secrets. We also don't want to push these images to our container registry. We don't want to accidentally deploy them later. So we don't need any of that. And so to that end, we can just, we don't have to log into Kubernetes because we're not using Kubernetes. We don't need to log into Docker because we're not using our Docker container registry. And so to that end, we don't even need this secret right here. We could just say full stack API -PR and do the same thing here. And that is our pull request build. Now it's still going to do all of the steps in our Docker file. So it'll still do the build and the test and the publish, and it will still do all the things. And depending on the other steps that we have here, we might push this to browser stack and launch a bunch of tests there, or we might spin up some GitHub services like a Postgres database associated with this build, do a flyaway migrate to get it up to speed, launch the container and validate. We can do all of those things as part of this build, but we just don't want to deploy it anywhere. Yeah?
For example, in case of tests, I see that you're doing tests on the Docker file rather than maybe in the GitHub actions.
Right.
I imagine something related with C# that is better on the containers, or why you choose to do it in the container instead, in the container creation process instead of the action.
Ooh, good call. Why did I choose to do the tests inside the container instead of inside the action? The goal of a DevOps build is to be in a neutral environment. And the cool part is there is nothing more neutral than in the midst of a Docker build. I'm not even taking for granted all the things on the GitHub Actions build agent. I am in a completely isolated neutral environment that I very specifically specified as my base image together with the things that I built. There is no contamination from outside. It's my preference. Some people really like to build out here and then copy the results into the container. Sure. But I really like having that completely neutral environment. The other benefit is that if my Docker file is misbehaving, I can do a Docker build locally. It will also run all of those unit tests and perhaps integration tests locally, and I can replicate the results without having to kick off another build. You know, commit another carriage return and delete the carriage return, and 20 builds later, it's like, well, why is this? I'll just Docker build on my local machine and I'll get to that same experience.
But you might want to do your end-to-end testing outside, right?
Yeah.
In some other runner.
And so that's where I would do npm run Cypress there and do the things. The cool part is I would first do a Docker run and in detached mode. Now my app is running. I might also want to set my connection string to the database that I have running here. And then I'm going to run my Cypress tests, harvest those tests locally. And yeah, now I've done all the validation, but it still hasn't left the agent yet. Yeah, integration, end-to-end tests happened there. That's pretty cool. So in this README, it might also be kind of cool to say, give a status badge of how the build is working. So let's go back into our build, and we can take a look here, and we can say, create status badge. And it will give us exactly the markdown that we need to create that status badge. So we can pop open this README file. Let's put that status badge right there. And now we've got a status badge to be able to show us a green or a red build. Back in our source control, we put our status badge in place. I'll stage that. We've got our PR build. It's a brand new build. That looks great. It looks like we might have trimmed a space off that. That's totally fine. And good thing we ignored that Kubernetes YAML file and Docker file so we don't actually accidentally get those in place. So I'm going to say PR build and status badge and commit. Last time we pushed on the command line. Here, let's push right here. Push these up to GitHub. And now we modified files inside this repository, so it's going to kick off another build. Now last time we went in this way. This time let's go in this way. We can see all of our builds here, and if we want to filter by a particular build, we definitely can. But let's click into our build, and we can see that do its thing. It'll log into Docker, it'll log into Kubernetes. It looks like it's doing the .NET build now. So we'll restore our NuGet packages, all of our dependencies. Looks like that works. Now we'll copy, we'll run a .NET build. Did I syntax error any of the C# files? Nope, no warnings, no errors, that's great. So now we don't have any unit tests, so we don't have any failing tests. We'll publish the results, flip over to the other image, and now we have the other stage. Now we'll flip over to our Node app, where we copied in our manifest. We'll npm install those dependencies. We can see why we want to move that stage up, because, well, this installing the npm dependencies is one of the slowest steps. And it's like, if React didn't change, I don't want to have to install React again. But it looks like our npm install is going to go great. And then we'll do npm run build, the Vite build that will deploy our static assets. And we'll switch over to the other stage, push those two things up to our Azure Container Registry, our private Docker Container Registry. We'll apply that new version, and we've got a green build. Back in our repository, you can see now we have that status badge on our repository, and that will always stay up to date. Now, one of the other things that we did here that is really cool is we specifically said, I would like to add the version label to each of the containers, each of the pods as they start up. So if we come in here and we say, get all the things, first off, we can see that these have been running for 36 seconds, which is not long enough to, I monologued for a while back then. But let's take a look at this backend API. And let's say kubectl describe that pod. And we can see all the events of how it was able to do all the things, and the taints and tolerations, which is interesting, all of the environment variables that are set, which, by the way, exposes that secret right there. And but if we scroll up, we can see the version. Now in this case, it's version 8834D. So if I do a git log -- one line, we can see that 8834D is our latest commit. So baked into the Kubernetes details is the Git version that we would need to be able to replicate the results with that image. I also like to bake it into the app so that maybe on a /version.html page or /version.json page, we can expose that version, and then we can do some cool checks like perhaps in the midst of the build, we say, oh, and by the way, after you deploy, wait for the deployment to finish, and then go curl that version page and make sure that the image, the version that is deployed is the one that we expected. It's possible that in the process of Kubernetes deploying, it failed and it automatically rolled back. And so the deployment succeeded because the apply finished, the deployment is live, but it's actually rolled back to the old version. So curling the page and validating that we've got it, or taking a look at that image label and taking a look at that version is a great way to be able to validate that we've deployed that new version successfully. So the cool part is all of the code that we just built is now up on GitHub, github.com/robrich/fullstack-DevOps Kubernetes, and you can fork this and start building it yourself, or give me a pull request and show me everything I did wrong. Give me details of how I can rig up the database. This has been so much fun getting to show you the full stack DevOps. Thanks for coming.